Now let's start with our next question, that is question number 22. This question belongs to section of mechanics. Now here the two satellites A and B have masses m and 2m respectively, and A is in circular orbit with radius r and B is in circular radius of 2r. So we have to find the ratio of their kinetic energies. Now let's solve this question. First of all, I would like you to focus on this diagram I have made for you. So as you can see here, this is the center Earth, that is capital M. This is satellite A, this is small m, radius would be r, right? And here would be the next satellite, that is 2m, radius would be 2r, right? Now in any case, for any satellite, always there is a velocity. Let's take it as v1, and for this let's take it as v2. So from here v1, I'll write m v1 square by r should be equal to the gravitational force by Earth, that is G capital M small m by r square. Solving this, you will get v1 square is equals to G capital M by r. That means the mass of satellite does not have any significance here. Only the v will hold a relation of this here. Now the next case, v2 square, similarly it would be G capital M by 2r, right? So we have two relations. This, let's take this as first equation, this as second equation. So from here you will find that ratio of kinetic energies TA by TB would be equal to half m v1 square by half 2m in v2 square. Solving this, you will get half of v1 by v2 whole square. This would be simply half into, you will get 2r by r. So this and this will be cancelled, you will get 1. So the ratio of the kinetic energies will be 1. Let's see which is the best suited option here. Among the 4 options given here, option number 1 is the right answer to this question, right? Let's move ahead and solve our next question. Now the question you see here belongs to a section of heat and thermodynamics. Here there is an ideal gas which is enclosed in a cylinder with a particular pressure of 2 atmosphere and temperature 300 Kelvin. The mean time between two successive collisions is 6 into 10 to the power minus 8 seconds. I hope you are aware of the mean free path. That is, between two collisions, a particle will move freely, and that is known as mean free path. And the time taken between the collision one to another, then that is known as mean time. Now here, if the pressure is doubled and the temperature is increased to 500 Kelvin, we want what happens to the mean time. Let's start with the solution. So I hope you are aware of this, that T is proportional to V by root of T, right? And volume is proportional to temperature by pressure, as for nRT is equals to PV. So I'll use these 3 equations and use V here. So I'll get V is proportional to under root of T by P. This is the important equation. From here I can write T1 by T2 would be equal to under root of temperature 1 by temperature 2 into P2 by P1. Just putting the values. So P2 by P1 is twice. This would be 300 by 500 into, this is 2. This would be T1, this would be T2. I'll get the value of T2 as 3.87 into 10 to the power minus 8 seconds, right? Let's see which is the best suited option here. So among the 4 given options, option number 4 is the nearest possible answer. So right answer to this question would be option 4. Let's move on to our next question, that is question number 24. So now this question 24 you see belongs to a section of electromagnetism, where there is a parallel combination of CR and LR, right? Now as per the question, this capacitance is root 3 by 2 mu f, R2 is 20, inductance is root 3 by 10 H, and R1 is 10. The current in LR1 is I1 and current in CR2 is I2, right? Now the voltage source has the proper rating of 200 root 2 sine 100t. This would be our omega. The phase difference between I1 and I2 is required. So let's start with the solution. So in this case, as per the phasor diagram, we think potential is making a common base. So for case 1, that is the case of inductor, you will say that VL by VR would be the phase difference between the potential and current in the case of LR. So here I will also write as XL by R1. What would be the value of XL? It is simply omega L by 10. Put on the values here, you will get this root 3 by 10 divided by 10. So clearly you will find that the phase difference value theta 1 would be 60 degree, right? So we know phase difference between the potential and current in LR case. Now let's talk the same about capacitance case. So that would be again VC by VR. This can be written as XC upon R2. XC would be simply 1 upon omega C into 1 upon R2. When you calculate this, you will get 1 upon omega C as 1 upon 100 and capacitance value is root 3. 2 will go up into 10 to the power 6. This value, whatever it will come, it will be 20 by root 3 into 10 to the power 3 ohm. You will find this XC value is too much greater than R2 because R2 is simply 20 ohm, right? That means XC is too much greater than R2. In that case, theta 2 would nearly be equal to 90 degree, right? So what's the phase difference between the potential and current in CR circuit? It's 90 degree. And there it was 60 degree. So total it becomes of 150 degree. So among the given options you can see 150 degree is nowhere. That means this question would probably be given as bonus to you. Now let's move on to question number 25.